What's up, guys? Welcome back to Chem 1 BSI. My name is Roane. Today we're going to be talking about some enthalpy of formation problems. So the first thing I want to talk about when we talk about enthalpy of formation is I want to talk about the types of materials you guys will probably be getting when you need to solve these problems. The main component being an enthalpy of formation table. Okay, so you might not get a table that looks exactly like this. You might get a table that is on the larger side, like this one, and has a bunch of different chemicals and a bunch of different substances and all their enthalpy values that you might not need for your problem, or you might get a very shortened down, concise version that only gives you enthalpy values based off of the substances you have in your problem. If you have, I just want to make sure that regardless of whatever kind of table you guys get, you guys know what you need to do and how to solve the problem. So the first thing I want to go over is this column here. So this column, like I have written out over on the right in red, these are your enthalpy of formation values. Okay, so, and what that means is all these numbers and all these values are the amount of energy that is transferred when you form a mole of the substance it's correlated to. And what that means is, if I was going to choose carbon monoxide, if I was to form a mole of carbon monoxide, this is the energy transfer. In this case, it's negative, so that means you're losing that energy to the environment. Okay, so and just to clarify, if you get a negative value, it's going to be exothermic. Get a positive value, it's going to be endothermic. But these values tell you what happens when you form a mole of that substance. So if I was going to form a mole of carbon monoxide, like I said, I'm losing 110.5 kilojoules from forming that mole. If I was going to form 2 moles, okay, I would just multiply that number by 2. But that's how these tables work. They're just telling you what's going on with the energy when you form a mole of that a substance. And from that, we'll jump right into our practice problem. Okay, so our practice problem here is I'm looking for the enthalpy of combustion, which is the enthalpy of reaction, for the following reaction. Okay, have my complete reaction here. However, I do need to balance it. Okay, so the first thing I want to balance is my carbons. Okay, I have 2 carbons on the left, so I need to put a 2 here in front of the CO2 to get 2 on both sides. I want to balance my hydrogens. I'm going to put a 3 in front of the water because I have 6 hydrogens on the left, so I need 6 on the right, so I put a 3 in front of water. And now I need to find how many waters I need. Unlike when you are balancing normal chemical equations, you are allowed to use fractions for this. So you can put 7/2. However, if you want to go and do it the way you guys are familiar with, you are 100% allowed to multiply the whole equation by 2, like we're used to. Okay, that'll get you the same numbers. Okay, so the next thing I want to talk about is, so when a molecule is in its standard state. Okay, so when you have something like hydrogen gas, okay, or chlorine gas, sorry, that's kind of messy, or oxygen gas, or even something like a solid Na, okay, anything in its standard state will not have an enthalpy of formation value. Okay, there will be no transfer of energy when you make these things because they're in its standard state. They're in the state that it would prefer to be in. If you don't put any reactions or you don't do any reactions, these elements will be found in these states, and there's no energy transfer when these things form. Okay, so any sort of gas in its natural state, solid in its natural state, usually those will have no enthalpy of formation. Okay, just to clear that up. So we have our balanced equation. The next thing we need to do is we need to go up, look at our table, and find the enthalpy of formation for all of our products and reactants. Okay, and if we add up all those enthalpy of products and enthalpy of reactions, we'll get the total enthalpy of the reaction, or the enthalpy of combustion. So I'm looking for my compounds I'm looking for compound, this one, this one, this one. And the reason I'm not highlighting O2 is, like I said, O2 is in its standard state. It's not going to have an enthalpy of formation. So that is going to be a 0 if I'm putting it into an equation, okay? So I'm going to look and find those values, and we have here, 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 okay? I'm going to take those values, I'm going to write them down here because they're useful to me and I'm going to need them. Okay, so I have all the values I'm going to need. The way you need to do these problems, okay, is the enthalpy of the reaction, or combustion in this case, but reaction is more general, is the sum of the moles times the enthalpy of formation for the products minus the some moles of the enthalpy of formation for the reactants. Okay. And what I mean by that is you just need to multiply each product or each reactant by the coefficient that is in front of it in your overall reaction up here. Okay, so for example, if I was going to start adding up my enthalpy of formation values for my products, okay, we can start with carbon dioxide. We have to multiply whatever my enthalpy of formation value is for carbon dioxide by 2, because there's a 2 in front of it in the in our overall reaction. So we're going to have 2 negative 393 plus 3 times negative 286. That's for water. Okay, so those are all my products. And then for the reactants, I only have one reactant, okay, because remember, oxygen doesn't have a value. And that's just going to be minus negative 278. Okay, and I'm changing it to enthalpy of combustion because that's what the problem's looking for, but it's the same thing as enthalpy of the reaction. Okay, and if you do the math on a calculator, you should be getting negative 1,367 kilojoules per mole. And this, like I said, this is your enthalpy of combustion or your enthalpy of reaction. Okay? So each separate molecule will have its own enthalpy of formation, but if you want to find the overall enthalpy of the reaction, you just need to add them up using the formula up here. So I hope that helped. If you guys have any questions, feel free to drop by office hours. And if you want any additional practice, there is a worksheet available online that you can test your knowledge on some of this enthalpy formation stuff. And there's a couple of practice problems with there. Okay, thank you guys. I hope to see you next week. I hope to see you guys in office hours, and I hope this helped.